everyone, welcome back. This is lesson 7 Properties of Logarithms. The objectives for today: by the end of this lesson, you'll be able to use properties to simplify logarithmic expressions, and you'll be able to translate between logarithms in any base. All right, before we begin, let's review what we know about exponents. In this first problem, we have 2 to the 6th power times 2 to the 8th power. Now remember, 2 to the 6th power means 2 6 times. All right, 1, 2, 3, 4, 5, 6, and 2 8 more times. So 1, 2, 3, 4, 5, 6, 7, 8. So in the end, we actually have 2 to the 14th power. And all we have to do is take our 6 and our 8, add them together, and we end up with 2 to the 14th power. Again, remembering that as long as your base is the same, all we have to do is add and our exponents, and we're going to get the correct answer. So remember, 3 to the negative 2 power is really just the same as 1 over 3 squared. So we'd have 3 twice down there, and then 5 on the top in our numerator. And now when we cross these out, we end up with 3 to the 3rd power. So remember, all we have to do is say negative 2 plus 5 equals 3. And so there we have our answer, 3 to the 3rd power. Now here, we're actually already have it worked out as a division problem. And just like before, we'd have 12 on the top, 4 on the bottom. 4 of them cancel out. So it's basically saying 12 minus 4 equals 8. So our answer is going to be 3 to the 8th power. So when we have division, we can subtract our numbers, and it works out just fine. Again, here we have division. We're going to look at this number first. 4 to the negative 1 power is the same as doing the reciprocal, so that would be 4 up here in the numerator, plus 3 more 4s is 4 to the 4th power. Again, 3 minus a minus 1 is equal to positive 4. So our answer is 4 to the 4th power. All right, on this next one, number 5, I want you to take a look at this. What does this 5th power mean? Well, it means we're going to take 7 to the 3rd power and do that 5 times. All right, 7 to the 3rd power, 1, 2, 3, 4, 5. All right, so now we actually have a very large number. So we're going to have 7 to the 1, 2, 3, 4, 5, 3, 6, 9, 12, 15. 7 to the 15th power. All right, and the rule then we can see is we just have to multiply our exponents together. 3 times 5 is 15. Again, all of these rules that we're learning with exponents, that we know with our exponents, are going to be true with our logarithms also. So here we have 7 to the 15th power. All right, and then just a quick review from yesterday. This log base x actually should be written down a little bit lower. And if we want to write that in exponential form, we're going to say x to the 1st power equals x. So that's going to look like this. And now on this next one, again, I like to put my 0 on the other side. So I'm going to say x to the 0 power equals 1. And there it is, x to the 0 power equals 1. All right, so now that we have reviewed our things about exponents, we're going to move on and transfer it over to our logarithms. All right, so remember that to multiply powers with the same base, all you have to do is add your exponents, all right? And we just did that a minute ago. So now we're going to talk about our first property of logarithms, the product property, all right? And let me just make sure you understand, for any positive number m and n, and b is not equal to 1. All right, so now that we have it. So the logarithm of a product is equal to the sum of the logarithm of its factors. Okay, so here we can see log base 3 1,000 is equal to log base 3 10 times 100. All right, so I know that 10 times 100 is the same as, multiplies together to get 1,000. So what I can actually do is I can add the two together. All right, just like I showed up here, I can add my two logs together, and so that is our product rule. So written algebraically, log base b mn is equal to log base b of m plus log base b of n. And we'll do problems like that, so don't worry about it if you don't understand it quite yet. Let's do some actual problems. So, and also it can go backwards. If we have all of these logs, we can add them together, and then just by multiplying them together, we'll get the final answer. So the properties can be worked in reverse also. All right, so let's do our first example. Here it says express log base 6 of 4 plus log base 6 of 9 as a single logarithm, and then simplify. So let's think about what we have to do and what we know. So we have log base 6 of 4 plus log base 6 of 9. So these are the same bases, so that means we can follow our rules. So to add logarithms, we just have to multiply the numbers. So we're going to multiply 4 times 9. So we end up, it's time to simplify now, log base 6 of 36. And now what we have to think about is we're going to have to solve that. So let's think of it this way. 6 to what power equals 36? 6 to the x power equals 36. All right, and we know 6 squared equals 36, so the exponent is going to equal 2. All right, I hope that wasn't too hard for you. Try one on your own. All right, this time you're going to express as a single logarithm again, and here's the problem I want you to do. All right, so turn your video off and give it a try. All right, I don't think this one is too hard, so let's take a look at it. The first thing we have to do when we add logarithms, we just have to multiply the numbers together. So we can see that log 5 equals 625 times 25. And then we're going to simplify that, and we see that log 5 equals 15,625. And if you didn't know that, you could put it in your calculator. We could say 5 to the x power is going to equal that, and you may not know it, but it's actually 6. Now, here's another thing we can look at. I know that 5 to the 4th power is 625. So this is actually 5 to the 4th power is 625, and I know 5 squared is 25, and 4 plus 2 equals 6. All right, so the log of 5 here, that was equaling 4. This one equals 2. We add them together, we get 6. Sometimes instead of multiplying it all the way out to get this huge number, it makes it more difficult. All right, here's one more for you to try. Turn the video off and give it a try. It's a little more having the fractions, but it's not any harder. All right, so first of all, to add the logarithms, multiply the numbers together. All right, so we're just going to multiply 27 times 1/9, and we simplify that, and we know that log 1/3 of 3. So now we're going to say, think to ourselves, what number can we multiply? What is our exponent going to be? 1/3 to what power equals 3? And that's going to be a -1. All right, so how did we get this? Well, if I start out with positive 1/3, and I know I want to get to 3, I know that this is going to have to be an opposite. So 1/3 to negative something, and I just want that 3 to equal 3, so it's just 1. So when you rewrite it, it equals 3. Hope that you understood that. All right, so let's remember that to divide powers with the same base, you subtract the exponents. So because logarithms are exponents, subtracting logarithms with the same base is the same as finding the logarithm of the quotient with that base. All right, so here's our new property, the quotient property. Again, let's just look at the algebra of it. The log b of mn is equal to log bm minus log bn. Same thing we did with our original numbers when we had to subtract. So the property can also be used in the reverse. And here's one word of caution. All right, just like a to the 5th, b to the 3rd cannot be simplified, that's as simplified as it gets. Logarithms must have the same base to be simplified. So we must have 5 all the way through. If we don't have the same base every time, then it can't be simplified. All right, so here's an example. It says express this function, log 5 100 minus log base 5, 4 as a single logarithm, and then simplify if possible. So the first thing that we want to do is just to subtract the logarithms and then divide the numbers. All right, so we're going to take 100 divided by 4, and when we do that, we get log 5, 25. And then to simplify that, remember, we just have to think, what we want to think is 5 to what power equals 25, and that is 2. All right, so here's one for you to try on your own. Turn your video off and give it a try. All right, so the first thing we want to do to subtract the logarithms is we have to divide the numbers. So we see that log base 7, 49 divided by 7, we know that's going to be 7. So we simplify and we have log base 7, 7. So what we're going to have to think is 7 to the what power equals 7. So I know that 7 to the first power equals 7. Because you can multiply logarithms, you can also take powers of logarithms. So that brings us to the power property of logarithms. So this says that the logarithm of a power is the product of the exponent and the logarithm of the base. So if my base is log 10 to the third power, I can just take this third and multiply it by my entire base. And so I end up with log 10 times 3. All right, so again, just looking at it algebraically, if I have my log and I have this a to a power, I can just bring that p outside, and then I can just multiply it that way. Let's do some examples. All right, so let's try this example. On a, we can use our power product rule and just bring our 6 down. And so we're going to have 6 times the log 2, 32. So let's look at log base 2, 32 equals x and find out what that is. So 2 to the x power equals 32. 2 to the x power equals 32. All right, well, I know that 2 to the 5th power equals 32. And remember, logarithm is just the exponent. So if my exponent is 5, my logarithm is 5. So all I have to do now is multiply 6 times 5, and I get 30. All right, for our next problem we're going to use the power rule again, and it's going to be 20. All right, and so now what our problem looks like is we're going to have to look at that log 8, 4 equals x. Let's see if we can figure out what this is. So this means take x to the 8 to the x power equals 4. Well, that's a little bit more challenging to know, but I know that it happens to be 2/3. And let me prove that to you real quick. Remember, 8 2/3 is the same as 8 to the 1/3 times to the second squared. Okay, because you remember with our exponents we can multiply those together, get 2 over 3. All right, and 8 to the 1/3 looks like this, 3/8, which equals 2 times 2 times 2 is 8, and so I can pull 1, 2 out. So 2, and then I have to remember to square it, equals 4. So yes, 8 to the 2/3 power equals 4. So remember, the exponent is the log, so I actually have 20 times 2/3, and that equals 40 over 3. Very long, but I don't think it's too hard. All right, so try one on your own. Turn your video off and give it a try. Okay, so on this one, remember using our power rule, we're going to just bring our 4 over. And notice I don't have anything in my base here, so I'm just going to be able to have to say log base 10, 10 equals x, all right? So I know 10 to the x power equals 10. 10 to the x power equals 10. And so I know that x has to equal 1 because 10 to the first power is 10. All right, so now I'm going to take that 4 that I moved over, 4 times log 10, and I know that my exponent is 1, so I'm actually going to replace that here with my log 10. And so 4 times 1 equals 4, and so that's your answer. All right, so let's look at number B. Again, using the power rule, we're going to move our 2 over to here, and we're going to take a look at log 5, 25. And let's see what that equals. So I know 5 to the x power equals 25. So 5 to the x power equals 25. So I know that my x equals 2 because I know 5 squared is 25. Now, again, that's my exponent. My x is 2 is my exponent. So this whole thing is actually 2. All right, so I'm going to take 2 times this log, which we know is now 2. And 2 times 2 is 4, so your answer is 4. All right, try this one on your own. Turn your video off and give it a try on your own. Okay, so using our power product rule, we're going to take our exponent here and we're going to multiply it by our entire log. And next we need to just take this piece right here. And so let's see, we're going to set it equal to x, and we're going to say 2 to the x power equals 1/2. So let's look at that. 2 to the x power equals 1/2. All right, well, I can see that that's the reciprocal, so I know that that means my x is going to equal -1 because 2 to the -1 power is the same as 1 over 2. So my x equals -1. So remember, this log is the same as my exponent, all right? So I actually am going to have 5 times -1, and 5 times -1 is -5. Okay, exponential and logarithmic operations undo each other since they are inverse operations. So let me just show you what this means. So let's take a look at this. It says log base 10 of 10 to the 7th equals, and I'm not going to put our 7 there, I'm just going to put x there for right now so we can prove it. Okay, we're going to use our little scorpion trick. So we know that 10 to the x power equals 10 to the 7th power. So therefore, my x must equal 7. So 10 to the 7th power equals 10 to the 7th power. Okay, let's take a look at this second one. It says 10 log 10 2. And again, I'm going to set this equal to x for a minute. And this time I'm going to use my backward scorpion. So I'm going to say 10 log base 10 to the x of x is going to equal log base 10 2. And once again, x must equal 2, which is what our answer is. Okay, so when we're looking at these, if we see, we just kind of need to learn these two. When you see your 10 and your 10, you know the answer is going to be that exponent. All right, so let's look at some examples so we can get some practice recognizing inverses. On the first one, letter A, I notice that my 3 and 3 are the same. And so I can see that this is going to be an inverse problem, so my answer is going to just be 11. All right, the second one is a little bit trickier. I don't see anything the same, and I actually don't even see an exponent up here. So I'm going to take a look at this 81. And I know that 81 is actually made up of 9 times 9. And so 81 is actually 3 times 3 times 3 times 3. So instead of writing 81, I'm going to change it to say 3 to the 4th power. All right, and now I can recognize my 2 3's here together, so I know this is going to equal 4. All right, see, these are going to cancel each other out, and so I'll end up with 4. Again, on the other way, I'm going to see I have a 5 and a 5 here, so those are going to tell me this is an inverse, and with that in mind, my answer is going to be 10. That whole thing is going to equal 10 since it's an inverse. Okay. All right, so here's 2 problems they're a little bit tricky to see if you really understand how to do these inverses and recognize them. So turn your video off and give it a try. All right, so you may not have recognized immediately that the base is the same, so we might want to re-look at this, and it's actually log base 10, since they don't tell us anything, 10 to the 0.9. So now we see our base and our number are the same, and so that tells us that our answer is going to actually be 0.9. All right, so There it is. All right, again, same here. You might not notice right away, but my number and my base of my log are the same. So my final answer is actually going to be 8x. Most calculators calculate logarithms only in base 10 or base e. But you can change a logarithm in one base to a logarithm in another base with the following formula. All right, so take a look at this formula. If I have log base b of x and I want to change it to base a, I'm going to take my new log base a of x and divide it by log base a of b, my x and my b here. So let's look at some real numbers. If I have log base 4 of 8 and I want to change this to log base 2, I'm going to say log base 2 of 8 divided by log base 2 of 4. And that way I can change my base. It's kind of complicated, but we're going to do some examples now. All right, here's an example to try. We're going to change log base 32(8) to base 10. All right, so the first thing we want to do is just go ahead, and I didn't have to write my base 10 in here because it's understood. So all I have to do is divide log 8 divided by log 32. And on these kind, you just really need to use your calculator. So when you put it in your calculator, you end up with this fraction approximately, and then working it out and dividing it out, you end up with 0.6. So once you can put that in your calculator and give it a try. All right, let's take a look at the same example again. And there's actually another way that we could solve this example. We could look at this log 32(8). And I know that 32 is, I could change this base to 2 because I know both 32 and 8 are powers of 2. I know that 2 to the 5th power equals 32. And I know that 2 to the 3rd power equals 8. All right, and so what I could do is I could just say, all right, log 2 to the 8th power is 3. So remember, I would just be doing this. 2 to the x power equals 8, which is what we did up here, and 2 to the x power equals 32, which is 5. All right, and now you just have to put in your calculator 3 divided by 5, and you get 0.6. So if you don't have a calculator or something, you could maybe try and do some problems like this too. Okay, so try this one on your own. Turn your video off and give it a try. The first way I want you to try is by doing it by the changing to the base 10. So all we have to do, it's really quite simple, is we're just going to divide log 27 divided by log 9. All right, so here's my 27 divided by log 9. Putting that in your calculator and dividing out, we end up with 1.5. All right, so go ahead and turn your video off again and try the next problem by taking a look at the 9 and the 27. See if you see anything common about those. All right, so the method 2, you would change to base 3 because both 27 and 9 are powers of 3. So looking at this, I know that log 327 is equal to 3 because 3 times 3 times 3 is 27, and 3 times 3 squared is 9. So I actually have 3 over 2, and then that would give me 1.5. All right, so try this one on your own. Turn the video off and give it a try, and I'd like you to try changing from base to just straight to base 10. All right, so that one shouldn't have been too hard for you. You just type in log 16 divided by log 8 and then divide it out, and you end up with 1.3. All right, so now I want you to think for just a minute, what base do you think that we're going to change this to? What base could we change this to? Do you see anything common about the 8 and the 16? I do. I see that they're both powers of 2. 2 to the 3rd power, actually we'll do 16 first. 2 to the 4th power equals 16, and 2 to the 3rd power equals 8. So 4 over 3 is equal to actually 1.3 also. Now your book actually recommends, or they showed it to you another way, and let's look at that. So here they changed it to base 4. I don't think base 4 is near as easy because they're both powers of 4. And the reason why is because I see log 16, 4 to what power equals 16? 4 to the second power. That's easy. But 4 to what power equals 8? I don't see 1.5 as easily, so I bring it on down to 2, base 2, and I think that I can see it easier that way. All right, so that's the end of our lesson of all the different properties of logarithms. Why don't you turn your video off and give this a try and just review yourself and see how much you actually remember of it, and then turn it back on and see how you did. Okay, so here are our solutions. Take a look and see. So here they are. All right. I hope you were able to get those, and we'll do more in class tomorrow. So if you didn't, we'll talk about it some more in class. All right, that's the end of our lesson. So have a great day, and I will see you later. Bye.